Hi everyone, this is Mr. Cardoso, and in this video we are going to talk about constructors when we're talking about objects. So, believe it or not, even though right now in our fraction class, this is our fraction class, we start with our instance fields. So again, that just a summary that those are what the object has. So a fraction has a numerator and a denominator, they're both of type int. Then we went straight to instance methods. So what can the object do? So this one, the toString, this is kind of like it can print itself out. So it can return a string representing what it should look like. It can multiply by another fraction. It can plus and so on. It can reduce. So these are some of the things that a fraction can do. Now, a constructor, usually for organization's sake, I mean they can go anywhere in the class, but for organizational sake, we like to put them immediately below the fields, the instance fields. Constructors. Now what does a constructor do? Well, what does the word mean, constructor? It means to construct or to build. And currently in this fraction class, we don't have any constructors. So, how does this actually work? Well, right now, anytime you use the new keyword, so going back to the fraction calculator class, when I go fraction f1 equals new fraction, and this new fraction here again, and this other one down here, every time I do that, I am using a constructor, right? But Mr. Cardoso, you say, you just said there are no constructors. Well, yeah, that's true. In fact, just like toString, before we wrote a toString, we could still print out a fraction. It just wasn't what we wanted. It would print, if you remember, the unique code with the class name. And in the same way, if you don't create a constructor for the fraction class or for any object, then Java will automatically create a default one for you. So right now, we're actually using the default constructor to create a fraction f1 and f2. And what the default constructor does, so if I draw over here, for example, f1, so after this line number 13, before we assign any values, it will create, because we use the new keyword, it will create that object. But for the numerator and the denominator, so it'll create it with all the fields that were defined in the class. So a numerator and a denominator, both of type int. But because you didn't initialize it to anything, there's nothing to initialize it to. We haven't done these two lines yet. So let's say we're just right here after line number 13. At that point, it will initialize these fields to the default values of those fields. So for example, ints will initialize to 0. And for example, if these were doubles or one of them was a double, 0.0 would be that default value. If it was a Boolean, the default value would be false, and so on. So that's the initialization that's taking place, and that is not good for a couple of reasons. The first reason is that it's annoying. Every time you create a fraction object, then you have to go ahead and assign the values right away, or at some point f1.new and f1.den gets a value, and the same thing for every other fraction that you've created. So we're creating more lines of code. It's a little bit annoying. It would be a little bit faster if we could do this a different way. So that's the first reason, annoyance. We don't want to, constructors help us avoid that and save time. The second reason is, in this particular case, for example, 0 over 0 is not a good fraction to have. It's actually indeterminate. It's not even undefined. It's indeterminate. It's not a good fraction. So that's if the secondary programmer, which we are here in fraction calculator, doesn't initialize these values, then we carry forward and they might do bad things with a 0 over 0 fraction. So let's avoid that, and let's go into the fraction class and create a constructor. So here's the rules for constructor. Usually we start with public. We haven't gotten into public versus private yet, so for now just throw public in front of everything, all of your method headers. So constructors are like a method header, are like a method. The return type will match. So what comes next, right? It's public and then the return type. the return type matches the class name. And that's because it is returning a fraction, right? It's creating one for you. That's what a constructor does. It builds the object. So it's constructing one and it's returning it. And so therefore, no method name is required in a constructor. Here, usually, we give it a method name. These can be anything we want, with the exception of toString if we want it to override. But these can be anything we want with good variable, naming conventions and so on. But there's no method name for your constructor. So we'll see why, because when you call it, if you notice, we go new fraction. So this is basically calling that constructor, which is a special case of a method, right? It's calling this one. So this doubles as the name as well as the return type when you're talking about a constructor. So now it's like, what do you need to be able to create this fraction, right? So it's nice to have a numerator and a denominator to initialize them from. So we're going to take this from the user. So these are both going to be of type n. So for example, int n and int d. Now all we do in our constructor, and later on we can do more things in our constructor, but for now all we do in our constructor is we basically assign these values that are coming in from the user when they call that when they use that new keyword, when they call this constructor. They're going to pass in two values, and we're going to take those two values and put them into the field. In other words, we're going to put them in here and create that constructor and send it back, and create that fraction and send it back. So we can say num gets n. So that's taking that n value from the user and putting it into the num field for that object. And then gets d. And that's it for now in our constructor. So if I go back here and hit the compile button, what do you think is going to happen? Well, now we've got compiler errors all over the place. Why? Well, when we created this constructor right here, you basically told Java, hey, listen, I'm creating the constructors. So do you remember the default constructor that we were using all along that has nothing in the brackets? Well, that default constructor is now gone. So you're going to have 3 errors here. 1, 2, 3. And even within our fraction class, where we created fractions, we're going to have errors there as well. So a couple of ways to fix this. We can actually, just go here and put these values directly in. So we can go, for example, 1, 2. So that works, and that's where, we can get rid of this now. We don't need to do that anymore. And if I compile this, remember we had 5 errors. Let's see how many errors we have now. So now we have 4 errors. So that fixed this issue. So before we fix the rest of the issues and talk about our options, let's look at how this works. So now we're saying new fraction 1, 2. Well, this matches the constructor because these are both integers. So that's an int and that's an int. And that matches this constructor that we have here, which is int and int. So when I put the 1 here and the 2 here, that 1 went into the num field and the 2 went into the den field here. So that would create, that would put the 1 here and the 2 here. And of course, in the fraction class, what's pointing? F1 is not pointing to this object. This is pointing to this object in this F1. So in fact here, we could even do this dot num to make it more clear, and this dot den. And remember I said that this is optional most of the time, but it makes it nice and clear that in these instance methods or constructors or whatnot, we're always talking about, when we use num and den, these fields, we're always talking about that implicit one. So who's the thing calling it? And in this case, we called it F1. F1 is the one that's being constructed. So it creates, this is now pointing to F1. This dot num gets whatever was put in here, in this case 1 and 2. And then you don't even have to put a return type here. We don't have to say return this. it's automatically going to return because it is a constructor. Okay, so that's how it works. Now, going back to how we fix our other 4 problems. So, there are times where we might want to, most of the time, like even in this one, we could have said, 3, 4. And that would have worked, and then we can get rid of this. So that's nice. There, save lots of lines of code. And even in here, we could have said, this is 10 and 8. We could have put 10, 8. And that would have saved it. These were for examples that we did previously in the previous videos. So now I'm going to go down here, but we're still going to have 2 errors. Well, we have it down here. Well, what about this one? This is actually inside the fraction class. So we created a fraction object called product, but we don't know what the values are until we actually calculate them here. If you remember, and same thing here, we have to use this formula when we're adding fractions and so on. We don't know what to put in there for these values. So, a couple of different options. What is nice to do is to simply put the default constructor back in. And yes, if you had the question, Mr. Cardoso, can you have multiple constructors? The answer is yes. So we can have multiple constructors. It's kind of like overriding your constructor. We talked about overriding methods in the last unit. So I can go public fraction, put nothing in the brackets, and then just give default values to your num field and den field. So I can go this.num gets 0, and let's say this.den gets 1. And now this constructor is specifically going to assign 0 over 1, so it represents the 0 fraction. Again, we don't like that 0 over 0. So when they use the default fraction, they're basically going to get a fraction of 0. And you can put that here in the comments. In fact, those are good things to put in the comments. So I'm going to save some time here. I'm not going to write the comments in here, but that's what you would write in here. This constructor, doesn't take any values, and it assigns a 0 to the numerator and 1 to the denominator to avoid 0 over 0 fractions. And that's something that you could put here in the comments. And in this comments up here, you could do the same thing, describing, what you would do for this fraction. This one takes a num and a den field and assigns the values appropriately, and so on. So now we compile it, and now we only have one warning. Don't worry about that, but we've gotten rid of all the issues. So now these ones will call this constructor because there's nothing in the brackets. So it will call this constructor here. And the ones that do have something in the brackets, 2 integers, it'll call that constructor there. So it's a lot more convenient to have these options. Now the user has 2 options to choose from. If they know what the values are, they can do that. And if they don't know what the values are, they can use the previous option. And of course, there's also the option, let's go back to this times one here. You can see we've got very similar lines of code in times and in plus. You could have also done this before. If we didn't put that other fraction back in, you could actually do this. Comma. So, and then we can basically get rid of this. And so I'll let you think about that. Basically, that's just calculating the value of the int, resolving it to an int, and then it's passing that into the constructor. Same thing's happening here. And in fact, if you want to do this in even fancier one line of code, you can even just do this and get rid of this right away. Now, that's, we jumped through a couple of hoops there, but we're following all of the correct procedures here. We're returning a new fraction, so we're matching the return type, and we're figuring out the int value here and the int value here, and then calling that constructor to create it and then sending it back. So all of that stuff's happening at once. I'm going to let you digest that line. It's an interesting line. Again, if you're not comfortable with that, you can always do it the long way as we have here, but you'll start getting, hopefully you'll start getting more and more comfortable with doing these little shortcuts and understanding how all of this works. Thanks for listening, and I'll catch you next time.